Thank you so much for having me here today. Thank you, Rashmi. I'm a pediatric gastroenterologist. I work at Children's National, and I have had the opportunity of working with Eric Hoffman, who's an expert in Duchenne muscular dystrophy, who spoke last year at the same meeting. I worked with him for several years, and I've recently had the opportunity to cut back on my clinical time and work with him in his company, Reverogen, to develop a medication called Vamorolone that I'm going to speak with you about today. So Vamorolone is under clinical development. It's now currently we're finishing up a phase 2A trial of Vamorolone in boys with Duchenne muscular dystrophy. And the phase 2B trial is set to start up in January. And this is, an experimental drug currently. So this is a slide showing you the general mechanism of action of glucocorticoids. Glucocorticoids bind to glucocorticoid receptors in the cytoplasm of the cell, and its effects are both nuclear and cytoplasmic. And you'll note that down here at the bottom, the DNA-dependent regulation depends on dimerization of the receptor. After the drug binds to the receptors dimerize, and then they bind to the glucocorticoid response element in the nucleus. This leads to DNA changes that lead to side effects that are associated with steroids. The anti-inflammatory effects of steroids are mediated both cytoplasmically and in the nucleus by a different mechanism that doesn't have to do with dimerization and binding to DNA. So this drug, Vamorolone, has a modification, a double bond at 9-11 position instead of a hydroxy group, and as a result, that modification prevents dimerization of the receptor. It does not prevent the drug from binding to the receptor, so it still has the properties that we want, the anti-inflammatory properties, but it doesn't lead to the binding at the GRE. And so it doesn't have the downstream DNA effects that we see with corticosteroids. And where this came from is an intersection of a few events. One, Dr. Hoffman, Eric Hoffman, has had a real interest in Duchenne muscular dystrophy, in which there's an abnormality of the dystrophin protein, which is important in plasma membrane stability in muscle. And so as a result, the muscle membranes are unstable. There's an inflammatory reaction that occurs in these muscles, and then over time, fat replaces the muscle, and these children get fibrosis of the muscles. And Dr. Hoffman had determined that NF-kappa B activation is very high in muscle in patients with Duchenne muscular dystrophy from birth. And at the same time, and a colleague of his, Kanappoina Nagaraju, also was identifying or developed an assay for NF-kappa B inhibition in myogenic cells. John McCall is a medicinal chemist who spoke with Eric Hoffman about this drug which can intercalate into membranes and stabilize membranes, and had been initially looked into for other indications in the past. And so there was a lot of interest in whether this could stabilize muscle membranes for Duchenne muscular dystrophy. And it turns out it also is a potent NF-kappa B inhibitor in muscle cells. So that really sparked interest in its potential benefit in this disease. And these are assays showing that it doesn't have the capacity to bind to the GRE in the way that prednisone does as a glucocorticoid response element, therefore indicating that it probably wouldn't have the same side effects as prednisone. And indeed, preclinical studies in mouse models of Duchenne muscular dystrophy, the MDX mouse model, we don't see the same growth stunting or the same abnormalities in bone in mice that are treated with Vamorolone that we do in mice that are treated with prednisone. And we also see that this drug Vamorolone increases the strength of muscles in mice in the MDX model as well. One additional difference between prednisone and Vamorolone is mineralocorticoid receptor action. So prednisone is an agonist of the mineralocorticoid receptor, whereas Vamorolone is an antagonist. And in Duchenne muscular dystrophy in particular, that's very interesting and appealing because medications like eplerenone are used in Duchenne muscular dystrophy to prevent the cardiomyopathy and fibrosis that we see in that disease. And indeed, in mice model, we don't see the same fibrosis that we see in mice treated with vamorolone that we do see in mice treated with prednisone. So in summary of vamorolone, this seems to be a dissociative steroid. It compares with glucocorticoids in the anti-inflammatory actions, but we may have some additional benefits like membrane stabilization, loss of those side effects that are mediated through the glucocorticoid response element, and the MR antagonist activities that could be particularly beneficial in Duchenne muscular dystrophy, but could also be in other people as well. So with this program of vamorolone development was initially funded by the NIH through an NCATS program, Trends at Therapeutics of Rare and Neglected Diseases. So initial funding came from that grant source and then also from extensive philanthropy support. And then subsequently funding sources like an SBIR and funding from the European Commission has allowed us to carry this drug through phase 2A and with funding through phase 2B as well. We've incorporated biomarkers into the vamorolone clinical development program because we want to show that this drug has a primary clinical outcome measure of improving an outcome for a child with Duchenne muscular dystrophy. So time to stand measure is our main clinical outcome measure. But we also want to show, and we want to see that this drug does have in children the same effects that we see in animals as far as safety benefits. And so we're looking at different pharmacodynamic safety biomarkers that are bridged to clinical outcomes of safety, and as well looking at some more exploratory efficacy biomarkers. And so for a phase 1 trial, which has been completed in healthy adults, we looked at pharmacodynamic safety biomarkers that are bridged to clinical outcomes, and then the phase 2 studies also looking at these safety biomarkers and some exploratory biomarkers that we've shown, and I'll show them a little bit further. So these are the secondary outcomes that are in which we're looking at biomarkers that are bridged to safety outcomes. So first and morning cortisol, fasting insulin and glucose, osteocalcin, CTX1. These are bone turnover markers, and then looking at white blood cell differentials as well. Steroids have the opposite effect on neutrophils in that we see this, huge increase in neutrophils, which is kind of like a pseudo increase in neutrophils as well, and that they don't exit into the tissue. And so this is data from the phase 1 trial in which we see that we don't see the adrenal suppression effects that we do with steroids. And we do, however, start to see the adrenal suppression effects at higher doses of vamorolone. As a result, our phase 2A trial and our phase 2B trial, we're only going up to 6 milligram per kilogram. And we're not using these higher doses that we saw these effects in the phase 1 trial. It seems to be a very well-behaved drug. And again, we're looking for these biomarkers which are known to be correlated with clinical outcomes. Efficacy biomarkers, more exploratory, of course. And so one thing that's been very helpful is the CINRG, Cooperative International Neuromuscular Research Group, with which Eric Hoffman has led for years. And so there's a lot of natural history data available within that study. I also have looked at pharmacodynamic biomarkers in children with inflammatory bowel disease, another disease that's treated with corticosteroids and is a systemic inflammatory disease. So what we did was a SomaScan proteomic study looking at 1,100 proteins that that can be done with only 75 microliters of serum, and basically took both a cross-sectional sample of children with Duchenne muscular dystrophy treated with steroids and a longitudinal sample of children with Duchenne muscular dystrophy treated with corticosteroids, as well as another cohort of children with inflammatory bowel disease treated longitudinally, or with serum samples collected longitudinally pre and post-treatment with corticosteroids. And we've identified a number of biomarkers that change across all of these different cohorts with corticosteroids. Now, these are not bridged to clinical outcomes yet. That's underway with longitudinal studies. But some of these biomarkers are very interesting and have effects that certainly could be associated with later outcomes or anticipating later outcomes. And so what we're attempting to do is to find biomarkers that we can benchmark to prednisone in our studies of vamorolone. And I should say that this yellow column here is acute longitudinal. So we had looked at children treated with steroids for several weeks in both inflammatory bowel disease and Duchenne muscular dystrophy, in some cases looking out to 3 and 4 months of treatment. But then we looked at IBD patients that were treated 1 to 2 weeks with steroids. These are newly diagnosed patients, not on anything else. They get 1 to 2 weeks of steroids. And we looked to see which of those biomarkers that changed in them more chronic treatment also changed in 1 to 2 weeks, to see if we could get a handle on, closer to the inflammation, cutting out some of the downstream effects that may be affecting these biomarkers, and also which biomarkers could we look at in our phase 2A study, which is only 2 weeks long. So we were able to come up with a cohort that seemed to change within that short period of time. And so in summary, both secondary endpoints, bridge to safety biomarkers are important for our vamorolone trials to help show that in addition to the clinical effects that we're seeing, and of course we're doing synactin testing and neck x-rays, there's a whole number of safety outcome measures that are being studied in the 6-month phase 2B trial. But in addition, these safety biomarkers will be helpful, particularly in looking at the shorter term trials. And then our exploratory outcomes, looking at non-bridged efficacy biomarkers, but we also have a pediatric pharmacology grant looking at these biomarkers in patients with Duchenne muscular dystrophy and with inflammatory bowel disease in a longitudinal cohort to try to see which one of these biomarkers that are early changing correlate with later clinical outcomes. And so for future directions, and Rashmi and I have talked about this a little bit, Eric has this idea that we could look at these biomarkers in a short-term trial of children with other inflammatory diseases to see if the same effects that we're seeing in Duchenne muscular dystrophy we see in children with other inflammatory diseases, to see if they may benefit from this drug also. And so as we gain more information about vamorolone during these trials, that's where we're looking forward to see if we can help other children in other conditions with this medication. And so these are my acknowledgments. There's a whole lot of people involved. I'm just one tiny player in this process. And, Erica has funding from multiple funding sources. There's just a lot of people really invested in helping in these efforts that we're very grateful to. So, thank you. I'm going to be around all day. If anybody has any questions, I'm happy to answer. Yes?
It seems like even before a lot of human studies, it might be through collaborations with people who have mouse models of asthma.
So they've been done. We do have them out. So it's been studied in multiple sclerosis and asthma models and IBD models and sickle cell disease. There's been a number of preclinical trials.
How do they compare to just standard steroids?
They work similarly in terms of their anti-inflammatory effects. So there have been several preclinical studies, and it depends on the model, of course, but that it does seem to be equally efficacious to prednisone in several different mouse models that have been published. Now, why did this move forward in Duchenne muscular dystrophy?
That's great that we came to here, but it seems like that's not the first disease you think of.
Yes, that's true, and it's a very good point, and I think there are so many possible directions that this medication could go down. I mean, it really came from the community that it was Eric Hoffman who started to develop this, in the community of Duchenne muscular dystrophy really got behind him, and that's really the main reason why it's moving forward in Duchenne first. He has a commitment to that community to bring it forward in that disease. But it has so many potential possibilities. And myself treating patients with inflammatory bowel disease, I know the devastating effects that steroids have on my kids. So, I see a lot of promise if it works the way that we would like it to. We're finishing up the 2-week phase 2A trial, and we'll have some early biomarker data soon, which will be interesting. Any other questions? Yes.
So my question was actually to the researchers here, is that if one was to test this in an animal model of SJIA, and I am aware there is no one animal model of SJIA, but I believe there are some approximations, at least. Is there anything, like what would be a way to get some animal evidence for this in SJIA?
Well, there is one animal model. At least the author of the paper claims it's mimicking the disease in a certain way. So potentially there would be a function test.
Okay. Any other thoughts on that?
If I can, I'm going to find you. If you
I don't
can.
think it has to be an animal model of systemic JA, and I think that the question is, does this treat a systemic inflammatory disease?
Well, that we have,
I understand
yeah.
You have data for that, but
Yeah.
I think that's the preclinical information you would need. Like, if it treats a animal model IBD, there's no reason to think it's not going to be special for systemic JA.
In IBD, our animal models are equally insufficient, and and so we've used it in these inflammatory models, full well knowing that it's not the same as in the human condition.
So if I may ask you now, what is the, in your understanding, what is the closest disease to systemic JIA? Like IBD would be the one where you have preclinical evidence?
I think so, and rheumatoid arthritis. It's been in we studied this drug in a rheumatoid arthritis model. No, Raju
Okay. Well, I didn't
has
know.
published, yeah.
So, from a patient perspective, this looks really interesting. Yeah, how many of the patient families here have their children been on steroids for long term? Yeah. So we talk all about the biologics, but the reality is, if you have a refractory kid, that child is on steroids.
And that's the reality in IBD too. I mean, I think when we talk about inflammatory bowel disease, we try to avoid steroids at all costs, but kids do end up on steroids for long periods of time, unfortunately, in these more refractory cases. So we still do use them. And I think that's probably the case with many inflammatory diseases, even though biologics are used widely now.
So, just openly, as a patient foundation, we are interested in being supportive of looking into this in SJIA, and if there are researchers interested, then we should talk, because I think this is worth at least understanding for SJIA.
We think so too. And we've been talking with Rajmi a lot, and we'll keep in contact with you as the trials progress. It was a paw model, a murine paw inflammation model. I didn't do the studies, but I'm going to get you the paper, though. I can get you the reference.
Maybe CIA collagen-induced arthritis.
I think so, yeah.
It's one of the standard models for RA drugs.
I'm going to, I didn't do the studies. Yes.
I just want to put some water in your wine.
Okay.
So, saying this without side effects is like a miracle.
So, yeah.
I believe what we can say is probably that there's less side effects with regard to metabolic effects and some other side effects that are very relevant without any doubt.
Right.
But what is very relevant also in these patients is, of course, the risk for infections. And this comes up as a risk factor in all the registries we have also for biologic agents.
Mhm.
Co-medication with steroids
Mhm.
is the major problem.
Mhm.
And what the medication
That's a very good question, one that I've asked many times too. And we're going to need to look into that more, for sure. And can you tease out and pull apart the anti-inflammatory and the infectious disease? I don't know. But that's a very important question.
And it's especially relevant, I think, for systemic AA, because
It is.
sometimes steroids are being used in the context of biologic therapy.
It is.
And Pharmacodynamic sister study of Joost has learned that if you use the combination, the risk of infection will increase to the
It's-
logarithmic.
Yeah.
And it depends also on the biology. So, for example, rituximab and steroids, it's a odds ratio of even above 100 for the risk of infection, serious infection. So, indeed, steroids are, as you say, are the main
Yeah.
reason for infections.
Thank you.